Alright, I'm back for chapter 3. I'm starting a bit earlier tonight. Hopefully I'll be a bit fresher while I'm doing my speed walkthrough of the chapter. I also installed this nice little app. Let me get it started. To help, it's called Cadmus. Let's see, I'll just turn it on quickly and you tell me if I get a better sound quality on the feed. Hopefully that, just enabled it now, so hopefully you'll experience better sound quality and not hear my computer whining away in the background. So just to recap, we're doing the QGIS for Hydrological Applications 2nd edition book walkthrough, which is authored by Hans van der Kwast and Kurt Menke. And in the first episode I did some basic tasks of georeferencing a map, digitizing and capturing some water features on that georeferenced map. Then in the second chapter we did more things with dealing with spreadsheet data. We had some temperature data which we did then, we did an import from a spreadsheet, and then created some interpolated surface, inverse distance weighted surface, and T-SYN polygon surface, and we could compare the two, and we did a little bit of sort of cartographic tweaking of the resulting imports. So that was all great fun, and today we're going to move on towards spatial analysis, chapter 3, spatial analysis with map algebra. If it's the first time you're tuning in, I don't know how much of a spectator sport this is, but basically I'm just walking through this book. It's a really nice book, and kind of like trying to speed do each chapter. So I don't read every single line, I don't read it out loud or anything like that. I just kind of look what they're trying to get us to do, try to copy the gist of each exercise as quickly as I can. If you want to chat to me while I'm working, please use the YouTube chat channel. I'm saying hi there now, because I'm not able to watch Telegram and Twitter and other things while I'm working so well. But I do have the stream on the second screen, so I can see that as well. Good. Okay, so let's dive in. I'm going to switch over to a screen share, and we can crack on. So today's chapter says with map algebra we can do calculations with raster layers, and that's very useful for spatial analysis. For example, when we need to evaluate different criteria to find suitable or unsuitable locations, we can use map algebra. So in this chapter we're going to use raster attribute tables. We're going to apply map algebra for raster analysis and look at different types of rasters like Boolean, discrete and continuous rasters. Make legends for these, understand the use of node data, logical operators, distances, reclassification, conversion from raster to vector, and sampling raster. So that's all fun stuff. Alright, so the first thing we're going to be looking at is this imaginary municipality, and they're giving us a case study, which sounds like fun. So in the case study there's 3 conditions. We need to find which wells are suitable for inhabitants based on the following conditions. The wells should be within 150 meters of a house or road. There should be no industry, mine or landfill within 300 meters of the well, and the wells should be less than 40 meters deep. So we've got all these criteria, and we're going to try to use some like multi-criteria analysis workflow to kind of identify which areas match those criteria. So let's go. So they're giving us a nice flowchart, which is not easy to show here on the screen, but they're kind of showing us the overview. I would say here for the old guys like me, if they could make the font a little bit bigger, it would be great. But basically, we're going to take a roads layer and then build a buffer around the roads layer, and then also some buildings layer, and we're going to kind of like class the buildings according to whether it's a house or a mine or industry, what have you, and then generate some buffers around those by the looks of things. And then we've got a terrain model, and we're going to find some depths for the groundwater depths, and then combine all those together to get a suitability layer. So that looks like fun. Okay, so I'm just gonna jump over into my file browser here to the data folder. In the previous recordings we've done here, I always show like I like to start off by going and exploring the data we're going to be using for the exercise first, just to get a sense of like what I'm going to be working with, or if they're referring to a layer or a data set, I know what it is. So the data is arranged in these 7 folders, and today's chapter 3 we're looking at, so I can come and have a look here. So I can see there's 4, I don't know why I keep saying 3 all the time. There's 4 data sets in here, and I'm just going to be a bit cheeky and just go and load them in QGIS quickly. You can just drag and drop them in like that, and you can see, okay, so there's a roads layer, and there's a groundwater level layer, and there's a terrain level layer, and there's buildings layer. So we're starting off with everything in raster format, which is cool. And as the chapter says, the focus is on doing raster spatial analysis. So good. Okay. No doubt going to ask us to add those one by one or whatever, but I've already jumped the gun, so I can skip through. They do a whole lot of things about adding directories to your favorites and so on in the browser, which that's a good suggestion. And then they say we should go look at the layer properties of the buildings layer. So let me turn off the other layers here. And you can just double click it to get the properties here. And I want us to look at all these stats here, and we can see, well, let's see if we can see anything interesting. So 60 pixels wide, 60 pixels high. It's integer values. The maximum value is 5. Minimum is 0. Now I suspect this is a classified layer, so each building type is probably 1, 2, 3, 4, 5 for 5 different building, or 0 for 6 different building types. So we'd have 0, 1, 2, 3, 4, 5. It would make 6 different types. All right. Now we're going to look at raster attribute tables, and raster layers normally don't have an attribute table, right? So you can't, if you click on a cell, you just get a value back like this. If you go here, you just get the value of the cell, but with the raster attribute table, you can actually attach text or other information to each cell value. So let's see. We need to install the raster attribute table plugin first, which is written by our good friend in the QGIS community, Alessandro Passotti. Let's have a look. Raster attribute table. And you can see Alessandro Passotti, and the description is very simple and clear. It displays and manages raster attribute tables. So we're going to go ahead and install that. And let's see what it does for us. We're going to have to go figure out how to use it now. I've never used it before, actually. So we install the plugin. Now we need to add a raster attribute table to the building layer. So I'm going to go to the buildings layer, and then the layer styling panel here. And then they want us to choose a paletted unique values render here, and we're going to classify it. I think they want us to classify, classify it. So without having a rat, they're saying we could edit these labels. For example, make 0 no buildings, no building, whatever. And we could give him each one a label, but you can't like add multiple attributes for a single value here, or it's not very portable with the data as well. So now we can go to the layers panel, right click on the layer and say new attribute table over here. So that raster attribute table added this menu item entry into the pop-up menu. Alright, oh, there's some layout issue, but anyway, okay, let's drag it a bit bigger. So there's a bit of a note there saying we do want to make a GDAL auxiliary XML file or a VAT DBF. Let's see what they want us to do. They want us to keep the default GDAL auxiliary XML. Okay. And now we get a message here saying there's a rat available. And I'm going to call it rats from now, and you know I'm talking about raster attribute table. Now with the raster attribute table, you can see we've got a lot of extra information connected to each pixel value. Let's see if we can. We can't change the color. Let's go back here and just make this, let's say, white. And that didn't update yet. Now you get it to update after you've changed the legend. Maybe that's a bug as well. I'm going to click off onto a different thing and open it again. Maybe we have to So maybe I found a bug already. Let me just save my work here. So I'm going to just save it and try closing the project and opening it again. Maybe that will sort of nudge it to rescan the table. Nope. You can't change this. Maybe we click over there and we can change it. Oh, I like that color dialog. That's nice. So it's funny now. It's okay. Okay, it's a bit confusing because you've got the highlight color is blue, which makes it look blue. Okay, but we were able to change it there. I'm next curious. I'm going totally off script here, but I'm curious to see if we edit the color here, if it updates over here as well. Let's go like this. Save the changes. So it didn't seem to update that. Did remember my change. And what does it draw to us? It draws it in brown. Let's change another one's color. Purple will be unmistakable. Save that. So basically I'm just exploring how this works before I get busy with the content. It's also a good technique if you're learning stuff to just have a little play with the things you're going to be learning about, just to get kind of a feel for it, so when you're doing the exercise things are not too foreign for you. So let's have a look. It's remembered it's purple, it's drawn it in purple, but number 2 should be purple here, but it's not. Let's have a look in the layer symbology here. So that purple doesn't seem to be linked in the direction of changing it in the attribute table, and then so there I changed that one, and yeah, you know, it's sort of like we'd expect it to be doing both ways. Like I change it in the attribute table here, and then I see the change on the canvas. So yeah, now it's matching. Yeah, that's a little bit confusing, but not too bad. You just basically, if you change something, let me try one more time. I'm going to make something black here. Let's make that black. Save my changes. So that's black now. That's still black there. I'll save the project. I'll open it again. It's forgotten about, well, it doesn't actually apply the black change here, and it's forgotten about it. Now if I do it in the other direction where I've changed it here, and then go back to the attribute table. It doesn't know about it there, but let's close the project and open it again. Now we've got black in the legend there, and still no black there. So yeah, I'm a bit confused about that, but anyway, hopefully in the exercise they'll lead us generally around that slightly confusing part of things. So alright, so they tell us to make a new attribute table. If we open the Raster attribute table, they're talking a little bit about different things you see here. So this is the count of pixels with that color, which is pretty useful to know. Then the class names, and then the RGB, the red, green, and blue values, and then the alpha, which is how transparent that pixel is. And then they said we can also add fields, we can make a new column, and they want us to name, add a new column. So let's go and do that here. Oh, that's weird. That's another glitch, because it won't let me edit. Let's just close the project again. Okay, you have to click on the table before those buttons activate for some reason. I don't know why that is. Okay, so let's add another column. Now they want us to call it for usage. They said we must use class name. For data type, we should use string, which means text basically, and the name we're going to put land use. Alright, and then insertion point before or after, we can put it after, and then put it after the class column. Okay, now we get a new attribute in here, and no doubt they're going to then tell us to make the different land uses. So 0 becomes none, and then 1 becomes house, 2 becomes public building, 3 becomes landfill, 4 becomes industry, and 5 becomes mine. Okay, so now we've got a new kind of attribute linked to our raster layer. We can save changes there. And then he said they want us to do the same thing for the roads layer. So we're going to go to roads. Here, we're going to open the raster table for roads. No, wait, hang on. Okay, so this pop-up thing, we just get rid of this. Here we go. So how do we add the table for that? Because I think I closed all those notifications and now I've lost the ability. Let's just to add the rest of the attribute table. Let's just close that and open it again. Okay, so that's for building. No, so I wonder if there's another way to do it other than this. We don't have the rest attribute table here. Can we go here somewhere and do it? So how do we get that option back? Oh, we just got to go here. Okay, so I think we need to classify the raster first before we can see it there. That makes sense. So if it's not classified, we won't be able to put like different classes next to it. So we're doing, let's not do that one, let's do that one there, and then we'll classify it with some random colors. Okay, and then when it's classified, okay, that makes perfect sense. Because if it's all just continuous numbers, there is no attributes that you can assign to it. It needs to know that it's a classified layer. Okay, cool. So we've got to work out the logical framework of everything, and then we're good to go. So let's open this one here. Now we're going to go repeat the same steps. We found our little bug again. That you do that and nothing goes highlighted. So you click on a row and then that appears there. We're going to put this after class. We're going to call it class name string, and it's going to be row type. Alright, so now we've got a row type column, and then they want us to make 0 would be no roads, and then dirt road would be 1, and then tarmac would be 2. Save those changes. Okay, cool. They do mention here you can also make rats for style pseudo color renderer layers, but you need to do some interpolation option to make it discrete so it gives ranges. Okay. So now we've got our 2 layers. I'm going to save my project again. We know what their classes are, and then we can use the processing toolbox in QGIS to provide, which will provide us some tools for doing some spatial analysis with these layers. So they start telling us to go to processing toolbox, which is over here, and we're going to find the houses which are within 150 meters of a road. Okay, so to do that, remember we're doing raster algebra now, so we can't just do a buffer on the roads because the roads are just pixels in a raster layer. So what we want to do is let's have a look first at the houses here. So we're going to create a Boolean layer with true for houses and false for the other classes. Okay, so remember our raster attribute table for this. It didn't remember my classifications are set for that. That's very sad. Let's go back and do that again. Need to see what the classes they want us to add are. Okay, so it's going to be none. Edit first. Say none. And then house. And then public building. Then landfill. And then industry. And then mine. Maybe I didn't save my changes, I'm not sure. Let's go and have a look. So I've done that. Save the project, close and open it again, and just verify that it actually did save that to the attribute table. Yeah, it did. So I don't know why I didn't do it the first time. I'm going to go and just set the same attributes for these as well here, just so that it's easier to see what's going on. House, public building, landfill, industry, and mine. Alright, so save our project. go back to the other page where they start telling us to use the Raster Calculator. So we're going to create a Boolean layer with true for houses and false for other buildings. Now here's another little bit of trivia. This Raster Calculator was something that Marco Hugentobler did for me for a project I was doing for GBIF, the Global Biodiversity Information Facility. Back in like maybe 2008, 2009 or something like that. And we wanted a way to be able to like do some raster calculations, so he wrote this very nice tool. And what it lets you do is like basically multiply layers together, like doing matrix maths like you would do in NumPy or something, but it's all done visually. So we need to choose an output layer, and they say we must call it something, so I'm going to go put it in the folder, chapter 3. They want us to call it houses.tif. Alright, and then they're going to give us a formula to use. Now the first thing we're going to do is, so we know the code of a house is 1, and we know the layer containing the buildings is this one here. So we can say double click this, and then we can say equals, and then 1 here. Let's see if that's what they did. Yeah, okay, and then that will give us a new raster where every cell is either a 0 or 1. The 1s will be cells that have houses on them, and the 0s will be ones that don't. The output CRS, did they want us to do anything special there? No. So let's have a look at our new layer. Hide that away. Okay, so we've got this new layer which is classified to buildings and no buildings, and we could do the same thing there by giving it a classification, classifying it, just giving labels for those things here. No buildings, buildings. Okay, and then what do they want us to do next? Now they want us to create zones of 150 meters around the houses. So to do that, we're going to use a different tool, not the raster calculator tool. They want us to use the proximity raster distance tool. So again, I think I'm just going to try to figure it out myself, and then so proximity raster distance. I want us to use this tool here, and I'm going to try it myself, but I just want to see what file name they want us to use for the output. It's not too important. Okay, they want us to call it houses 150 meters, so it's going to go here, and then save to file, and put houses underscore 150 meters. So that's all pixels which are within 150 meters of a house. And then for the options here, we need to make sure we've got the right input layer, which we do. So the target pixel values we know are going to be 1s, and the maximum distance to be generated, we want to be 150 meters. Now this data is in, it's in a projected coordinate reference system. It's funny because I thought some of the layers were in WGS34, but the project is in 32630 projection, so that I presume it's going to work in meters. So then we want to know all the value to give all the pixels that are within the max dist, and we'll just set them to 1, I suppose. Let's see if that's what they did. Yep. And then the output data type, since we're only going to store 1s and 0s, we can put it to just a single byte to make the data set smaller. I think we're ready to go. Let's run it. And now we get a new layer. I'm just going to keep that open so I don't have to do that all again if I'm not happy with the result. So here's our house is 150 meters. Now let's compare that. I'll use this little trick again of putting the transparency slider into the layer. That doesn't look any different to the houses layer, so I think I've done something wrong. Let me see. I've got the dialog still here. Let me see if I left something out. Maximum distance, 150 meters. Distance units. Georeference coordinates. So that's probably the reason. Let's run it again. Looks just the same, right? Let me just delete that layer there. Okay, there we go. So that makes more sense. So we've got now these little buffers around every building. It's funny that those look like cool little characters. It's funny that the buildings themselves didn't get classified as one as well. So I'm going to just check these parameters one more time, because I would have thought buildings 2 should be given value of 1. So no data pixel, no data value to use. Let me see what their output looked like. Okay, look just like mine. So I would have liked to have seen the dots in the middle also be classified as house. But anyway, there we go. So that looks just like theirs, and then they say we should classify that again. So let's go here and say classify. Okay, so then we got far from houses, and we've got within 150 meters to house, whatever you want to call that. Okay. Okay, and then we're going to do let me just see, because maybe I skipped a step here. So reclassify by table. Okay, so I think everything's done there. Said we should make them green and red, so let's make these ones green and these ones red. Alright, okay, now they want us to create zones of 150 meters around the zone, around the roads. So we can do something similar to what we just did, but now we'll use the roads as input. So there's roads. So they want us to give a list of pixel values for the roads. So let's just go here, turn on the roads, and I think we know that 0 is no road, and then probably 1 is minor road, and 2 is major road. No road, minor road. Could be the other way around. Major road. and then we're going to reclassify this now, but we want to do it on both 1 and 2. So in this dialog here, they said a list of pixel values. They say list, I presume we must give like that. It's not clear, or how do we separate them? Okay. The coordinates can be geographic coordinates. We're going to do 150 meters again. The value to be applied to all pixels. Hi Hans. I didn't set the distance to georeferenced in the previous one. Yeah, I think I did a second round of that and set it to georeference distances. So I landed up with something like this here, which looks similar to what you had in the book. And now I'm busy doing the roads. I'm just checking to see. We're also doing 150 meters from the roads. I'm going to set the value to byte here. Feel free to jump in, Hans, if you have any comments for me. I'm doing it like probably the not recommended for students way of just like half winging it and half following the instructions in detail. So sometimes I might run into some issues, but so far it's going well. I did find some little issues with the Raster Table plugin sort of not syncing the changes to the colors you make here. Right, 150 meters, we want to make them what? 1 if it's within 150 meters of a road, otherwise go to 0. Georeference coordinates, I'm still not sure about this list here. How are we supposed to separate the list? So I'm going to run it and see what we get. I think that looks good. I'm again unsure why the destination pixels don't also get classified as 1. Because I would have like filled those in, but maybe that's coming. Maybe I'm jumping the gun a bit. Okay, cool. So I think I'm happy with the roads. I'm going to just look in your picture to see if we match. Let me see if there's a picture. Okay, there's no picture of the roads, but let's assume that we're good to go with the roads. And then we're going to create another Boolean raster for true for industry, mine and landfill, and false for other buildings. So now we get to use okay, hang on a second. We first got to do condition 2. No industry, mine or landfill within 300 meters of the wells. So we need to reclassify the building in such a way that the result is a Boolean map with true for industry and landfill and false for the other classes. Then we need to calculate the distance. Okay, so you're going to go show us some steps now to do that. So I think we can close this. We're done with you for now, roads. So let me just read again carefully. So we want to create a condition where we reclassify the building layer in such a way that the result is a Boolean map with true for industry and mine. So let's look at our building. Is it the, yeah, it's the original layer, right? Building layer. So we want to have industry and mine given a 1 and landfill, and false for the rest. So industry, mine and landfill, so 3, 4 and 5. So let me see if I can wing it again. So we want to take the building and we can say I think we could get fancy and say in, and then we can give it a list of numbers here. 3, 4, 5. Let's see, it says that's invalid. So one of the nice things in the expression dialog dialogue in the rest of QGIS is that you get that interactive help. Let's see if we get any help when we click here. We do get straight to a nice page in QGIS here, on the QGIS website. Let's see if they tell us how the in should be used. Searching for in is probably not so productive because it's a very common word. But, let's see if we can search for in space bracket. I don't think they have an example. Alright, so documentation didn't help us too much there because we still don't know what the formula is. It does say it's invalid. Maybe we need to do if building in one. I'm going to put that all in a thing like that, and then we put the true condition, like let's see what they want. We give it a 1 if it's one of those, and then otherwise a 0. Still says that's invalid. I can't actually tell if that's in or L, eh? I don't think that's actually in. I think that's another function. Yeah, that's natural logarithm. That's Hans is saying there in the chat. Oh, why did they put that one in small letters, that one in small letters, and the rest in big? Because poor old sods like me with bad eyes, I can't tell the difference between the two. That would have been a nice function to have there. Okay, so the second way to do it is going to be just going to say like a bunch of if statements. So we say if building in building equals 3, or we can just copy building equals 4. Let's go check the syntax for if again. I really should look at your notes, Hans, but I'm going to look at it in a second and see these kind of things. If you don't use it every day, it's easy to forget the syntax, and then you're just going to have to Google if building equals 3, I think, and then the or clause should be if building equals 4, maybe. Let's try it like this. So Hans is saying I can use the comparison operator just to see if it's below 3. That would be a good choice as well. Let me just see if I can get the syntax right here, just for fun. Building is equal to 5. Then how would you do that? Then we'd have to say, because there's not an then, so each one of those would have to be like this. If it's equal to that, then make it 1, otherwise make it 0, or if make it 1 or make it 0. Yay, I've got a valid expression. So that might have worked, but like you say, that's very verbose. So Hans's recommendation, which is much better, is to say, I could get rid of all of that long verbose thing and say we want it to be greater than or equal to 3, then assign it to, then we'll get a 1. It's a Boolean expression, right? And then if it's not that, then we'll get a 0. I think we could definitely improve our docs on that, on this tool. It would be nice one day to be able to use the normal expression system in QGIS to do these kind of things, because then we can have all that rich help system. Okay, so right, that's a valid expression. I haven't set the output layer here, so let me call this now. Let's see what he wants us to call it. And I went on a total tangent there, right? But anyway, it was quite fun. So what do we want to call it? So let's look through the book here, see. I don't know if now 3.4 we're doing like a whole, if the first paragraph is a summary of the steps to come, because then it goes on to talk about doing the building classification. I'm just flipping forward to see where we're going to go with this, but it doesn't look like it. So there's no name given for the layers. I'll just give it my own name. For the second condition, we first need to reclassify the building layer in such a way that the result is a Boolean map of industry, mine and landfill, and false for other. And then, so I just did that, but I don't know if I'm going to get the instructions that come later or not. I'll just give it a name like undesirable land use or something like that. TIF. Alright, let's run that. Okay, it may or may not be the right thing to do, or I might have gone just totally off the reservation there. So let's go on. So we want to now create a Boolean raster. That's what I just did. So you're saying go to reclassify by table. So this is actually another way to do it, which is using the reclassify by table thing. So I used the Raster Calculator to do it. Okay, so I sort of understand how far off the reservation I went now. So let's go here, and we're going to probably make the same product again. Reclassify by table. Hi, John. Yeah, thank Hans, who's in the chat there. This is all his intellectual work, and I'm just following his book. So if you have any questions, feel free to ask. Hans is here, and between Hans and myself, we'll try to answer you. So I should be making now another copy of this layer, but just in a totally different way. Let's see. So I want to just check if I had, so buildings, I've got the rat. I want to go look at that rat again and see I've got those classes there. So somehow we're going to be able to use these classes with that tool to actually do some geoprocessing, which is very exciting for me because I never tried that before. So we're going to do buildings. Am I doing the right thing? Reclassify by table. Raster analysis. Figure 318 on page 62. We're going to reclassify the building raster using a lookup table. So I chose the wrong tool. I see that. So I need to go here and say reclassify by table, not by layer there. Alright, so now we should find, here's the reclassification table. So again, I'm going to try to just wing it a bit here. So we're going to see, let's add a row here. So minimum value, maximum value. So we put 0, and we know that we want 0 to 2. I don't know if it's inclusive. Should be assigned 0, and then 3 to 5 should be assigned 1. That should give us the same product as we got from this undesirable land use. So let's go and see, we're choosing the buildings. There you can see whether it's inclusive or not. So the minimum value, minimum must be less than the value, and the maximum can be greater or equal. So it's inclusive on the upper side. So that's great. So then we can make that a byte as well. And we're going to save that as, we'll call this V2 or something. Maybe we actually get the name now that we should be calling it because I ran ahead. It's called industry. Okay. Alright. Okay, and then okay, so I'm just looking to see the lookup table. Put in the lookup table as shown, so I'm going to just check. So he didn't use ranges, he rather did just discrete values, kind of like my first formula was doing, but let's see how it works with my ranges, if it works well. Invalid value for a table, this must contain multiple of 3 elements. Invalid use for table, this must contain multiple of 3 elements. Oh, it lost all my work. Why did it lose all my work? Okay, let's try again. 0 to 2 gives you a value of 0. 3 to 5 gives you a value of 1. And then we have to say okay. Okay, so if I went in there and then click back on here, it sort of chucked my changes away. I think that's what happened. Yeah, thanks Hansi. Okay, you're saying the same thing I just discovered. That I think that could be seen as a bug, right? Or at least maybe give you a little nudge saying, okay, you're going to lose changes when you go back. Let's try to run again. No error this time. And let's see if the industry layer... interestingly, it's 1 pixel different there. Why does it have a different pixel for that one? Let's go look on the original buildings layer. That's green, that's landfill. That was the only landfill pixel on the map. So maybe when I did my formula before I made a mistake. I'm not going to spend time worrying about that. So, or maybe actually wait, maybe it's the exclusive ranges. So landfill was, we don't want to build, we don't want wells near landfill. I'm going to just run that again. Reclassify by table. Building G. Let's do this again. 0 to 2 gets 0, and 3 to 5 gets 1. 3 is excluded because, why was 3 excluded? Let me go look at the logic again. Put that to byte. The min, it's not less than or equal, must be less than the value. Okay, so we can change this to less than or equal to, and less than or equal to max. That should do it then, I think. Again, just got to pay careful attention to those little details, right? So let's take that away and make a new one, and I'll actually just look at it before I close it. Okay, so now we can see land use, landfill is in our layer, and it should kind of match this one here. Let's have a look. The colors look a bit different, but that's not the problem, I don't think. Cool. How's that looking, Hans? I think we're good there. I'll close that and save my project. See what's installed for us next. So that was quite fun. I haven't used that tool before, Reclassify by table. That doesn't use the raster attribute table, so I'm still wondering why we use the raster attribute table. Maybe there's something coming along in a minute or two that will let us leverage that. But okay. Now we're going to find wells that are less than 40 meters deep, and I remember we added this groundwater level layer here. Let's just hide some of those. Now, why does that look so weird now? But I'm going to just go and change the look of it a bit and see. I thought when I looked at it before it had a continuous surface, but maybe it's just at the wells. Let's flip that around like that. So deep wells are red and shallow wells are blue, but the minimum value is 127, and they want to find ones that are less than 40. So again, I'm a bit confused because let's see what layers. We've got a well depth layer. Where's our well depth layer? We have to subtract the DTM from the groundwater level to do that. Okay, so I think that makes sense. So the groundwater, let's say it's 100 meters below the ground, but that's measured, I think, against sea level, if I remember my work with the folks from that are doing groundwater inventories. And so we want to know, this is above sea level, that's below sea level. We want to subtract the two. I think that makes sense. And so you can tell me if I've got it wrong. Yeah. Okay, Hans is saying that the PC raster tool, we can actually use those rat tables to do some extra magic, but it's not covered in the tutorial here, but it will be covered if you follow his video on YouTube channel. Feel free to stick the link into the chat if you've got it handy there, Hans. You can send people to have a look at that. Okay, so we've got these two layers, elevation layer and depth to groundwater, and we want to subtract them. So again, I'm just going to read what he wants to do, see if I can do it myself, and then otherwise kind of look at the instructions more carefully. So we're going to use the Raster Calculator again. I think it's just subtract the two. So Raster Calculator, I'm going to do, now we want to take the DTM minus the groundwater level, I would have thought. And we want to make a new one which is called well depth. Well underscore depth dot tiff. Okay, so Hans is correcting me a bit here. He's saying that DTM is the elevation at the surface. So that's above sea level, I guess. And then the groundwater level is relative to the same reference as the DTM. So by subtracting the two, we get the depth to the water table. Let's subtract them and see what we get. One of the things I like about the processing tools is that the tool stays open after you run it, so that if you made a mistake, you can tweak and run again. So let's go and have a look here. This is our well depth layer that we just made. Pseudo color it just for fun. I'll invert that. Oh, my geese are arriving at the door now. You might hear some noisy pecking sounds because they like to peck on the glass. I'm going to now use the identify tool and just look at these well depths. That's 4 meters, 67 meters, and if we compare those to the groundwater level, it was 274 meters, and then compare that to the DTM. So that's 270 where we now. The DTM, the terrain was at 279 meters. The groundwater depth was 274. So it's basically altitude above sea level that you strike the water, and then you want to subtract the land surface height from the water surface height to find out how far down it is, which is shown over here. I think that's perfectly logical. That's nice exercise. Okay, so we've got our new layer. I think now we're going to be doing, let's see, we want to get the layers that are less than 40 meters deep. So we're going to use the Raster Calculator again, and we'll do a Boolean Criteria to find out everything that's less than 40 meters deep. So let's see if we can wing that again. So we've got well depth is, so we'll give it a 1 if it's greater than 40. No, if it's less than 40. Less than or equal, let's see, what do they want? Less than or less than? Less than, okay. So everything that's less than 40 will get a 1, and everything else will get a 0. Let's go and, you said to call it not deep here. And I need to step away from the mic for a second just to get to turn on my light because I can't read Hans's book at the moment. Alright. Let's go, let's see what that does. Okay, so now we got a new layer which is all the points but just marked in yes and no. Let's turn that into a classified layer. This one is too deep, whatever, too deep. And this one is not deep. Okay, so green means you can drink the water from it if it's not close to, well, but you're still going to find out if it's close to industry or something like that. And the pink, not. So let's just double check that against our well depth to make sure that I didn't screw up my formula. So pink, let's go to here. Pink on here means it's not too deep. So in theory, if I click on this pixel, it should be less than 40 meters on this layer. So let's go and see. It's 19 meters. Oh, that looks good. Alright, I'll be right back in 1 second. I'm just going to turn on my light. Okay, so we've now got, let's do a little quick summary of what we've got. We've got wells which are not too deep to drink from. Let's make a little group here for that. Where did that go? I knew you were going to do that. Come on, get up there. Okay, so we've got wells that are not too deep to drink from. That's one thing. And then we've got houses that are within 150 meters of a road. That's another thing. And we've got the land use. We've got the land use is industry. Now why has that got a value of 3 in that? That's confusing me because I should have made that a Boolean layer, shouldn't I? I might have done something wrong with that. Or maybe that classification table, I didn't set the value right or something. So I think these values are 2. Let's go test that. That is, oh, that's 1, that's 0. But where's the 3? Let's go classify it and see. Maybe it just, there is a 3 there. Is there one pixel with a value of 3 somewhere on my map? Let's go see. No. That's weird. I guess that tool maybe has a quirk or something. Maybe Hans, you know why it does it when you do it that way. The one that I did myself in the Raster Calculator, let's go like that. That one had only 2 values. That's why we got the grey that I said earlier wasn't an issue. I still don't think it's an issue, but it's just a bit inconsistent. So there we got only 2 values in the legend. 1 which is industry and 0 which is not industry. But here we got 3 values, and I don't know what number 3 means. But anyway, so let's go. That's industry, not industry. Hopefully if you're following along, you see that we're building up a picture of sort of all the different components of the spatial arena that are in different, that meet different criteria. So here's all the industry places. Let me turn off this one here. Here are all the houses which are within 150 meters of a well. Here's all the wells which are not too deep to use. And I think we had one more, which was when you were within 150 meters of a road. Here, this one here. So we put this in our little group as well. So these are, you can call this group criteria something. And then the rest of these things are mostly input layers. Right, except for one of these was actually my my own sort of calculator thing, but I'll just leave it there, or just make it a little group of its own. So just organizing my thoughts and my data along in a way that I can quickly come back and look and see, okay, what was I actually trying to do here, what were the different data sets. I'm just trying to get this out of here, so let's put it like this. That thing's sort of floating freely, and I'll just save it. So these criteria, the 4 criteria we have are pixels within 150 meters of a road, industry cells where we don't want to have draw water from a well within those industries, houses which are things that need the wells, and then wells that are not too deep. Cool. Hans, if you have any suggestion as to why the pixels that were on the road, for example, were not coded as 0, I'd love to hear it. Maybe I did something wrong, or if that's the way that distance calculation works, why it works like that. Okay, so let's go and see what's next. So we've got the wells that are less than 40 meters deep, and then you said style the layer, which I went ahead and already did, so I think we're good there. Call them deep and not too deep, what have you. There's some questions here about, is the well depth layer discrete or continuous? So I would say discrete. So now, let's see. We can go on to the next page, and I'm just a bit unsure of something here, because I'm looking at the pictures in the book, and the industry the result of the second condition, 300 greater than or equal to 300 meters from industry mines or landfills. I don't think we've done that yet. But the well depth is continuous, but the ones which are deep or not deep are discrete. Were you asking about the well depth? Oh, you were asking about the well depth, yeah. Well depth is indeed continuous here. So did I miss something, or where is this result of the second condition where the cell which are greater than or less greater than or equal 300 meters from industry mines or landfills? Okay, I did miss that step. So we're going to do an industry distance one, and we're going to use that proximity one again, I guess. So what I like about your book, Hans, is that you do the exercises in a way multiple times. So the first time we have to follow it step by step. The second time we should have kind of like hopefully learned the procedure and be able to get some experience doing it ourselves. So let's see now. We've got where is that industry layer? Industry layer there, and we don't want any pixels which let's go to here quickly. We want everything that's within 200 meters of a pixel coded as 2. I should have left you can still see the as 1, sorry. And it didn't have a 2 value either, that's also strange. Okay, but anyway, so we want to find pixels within 300 meters of that. 300 meters. Value to be applied to all the ones within that distance should be 1. The rest should be 0. So let me just check quickly. Raster distance tool. Make sure that industry is the input layer. We're going to make this a byte again, I think. I'm going to save this to, it says we should call it industry distance. Cool. Right. So now we're back using a processing tool. We've got the advantage we can rerun it again easily if we make a mess up. So I'm just going to run it and see what we get. So it honestly doesn't look any different to what we had before, does it? List of pixel values. There we go. My same mistake as before. So just run that again. Let's just get rid of this. So you need to use the map distance, or the distance on the georeference dataset, not pixels. It's strange because if you'd think with pixels it would actually be making quite massive buffer distances around it. There we go. So when again I look at Hans's picture, those little blobs are solid in the middle. Mine are not. So I'm confused. I must be doing something wrong. But the question is what? Maybe I missed a parameter somewhere. What do you think, Hans? If you're still watching, do you have any idea why I get little donuts? Yours are filled in ones here. No data to use for the decimation. Let's see what these ones are coded as. Just get some better understanding of what you've got here. So that's 0, 0, 1, 0, 0, 1. used a different way, but the result you didn't use the max distance. Okay, I missed. So I missed something. So Hans is explaining that although what I've done is right, it's also wrong, basically, because what he did was he created a distance surface first, and then applied a raster calculator. So I think if I put this, leave it out, I'll get a new layer which is the distance of every pixel from any industry pixel. Right, like we do in grass in the old cost surface. So let's just remove that again. Another little quirk of QGIS: if you create the same layer twice, you've got to sort of unload it and reload it. Just run it again. Okay, but I guess every pixel now should be a distance. No. You didn't use maximum distance. Then I must leave this out as well. Take that away again. Alright, so I went way off the reservation. But let's see. I'm expecting to get a distance layer here, but I'm not. Ah, that's got, yeah, I've got a distance layer now. If you look here, these numbers, every pixel's got a different distance. It'll be easier to see if we change this to something like that. They're classified as one. No, that's weird because this isn't. Let's put it two discrete values here. No, it won't be discrete values, but it should be. I think QGIS is a bit confused about this layer, so I'm just going to take it out and add it back in again. Industry distance. Okay, I can already see it looks better there. Okay, I think just QGIS got a bit confused about how to display that because I'd had it in already classified or symbolized in a different way. Now we can see these are distances, right? So 255 must be no data. My confusion hasn't quite ended yet because I don't know why it's only calculated up to there. I thought every pixel would get a distance from a land use, from an industry layer, from land use equals 1. And so I'm not sure why I'm getting all of these 255s, which I think are basically just no data pixels. Unless, they were in the original, they were no data pixels maybe? No. I'm very confused about why that is the case. Remove the option 1 and check. Remove option 1. I'm saying remove that one maybe. Let's see. Let's add it in again like this. So I get 255s. Let me just work through everything carefully now. So we've got the industry layer, which I think that layer is fine. I'm going to just check it again. This industry layer, it's got this like slightly confusing thing here with these 3 pixels, which are not actually, there's no 3 pixel, but these cells are 1 if it's industry, bad industry, let's say, for drinking water, and 0 if it's fine. So we're trying to calculate distance from this layer, so I must check that I'm using industry as the input I am, and then if I don't choose anything for this list, it doesn't make too much sense to me, but maybe I need to just check quickly again. I should be using 0. I was using the wrong one there, I think. I think that's it. Let's run it again. This one here. Yeah, it can't be emphasized enough just to check the small details always and see that you not doing something dumb. So now I've got the reverse of what I want, because that's now doing it. The distance is within that, so it actually didn't do what I want. But I'm sure it's something to do with one little detail that I've got wrong. So let's see. Distances to be considered target pixels. Pixel values to be considered target pixels. So if I look at this industry layer here and I click on that, that's a pixel value of 1. Okay, so it was right. Those are the target pixels. So 90% of the time you're doing something wrong yourself, and then the other 10% there's a bug. And it's figuring out whether you're in the bug space or in the you're doing something wrong space. I don't know if there's a threshold that it stops, because 255 is like very significant kind of like byte. It's bytes. I changed it to bytes. I was looking at this number thinking, why is that so, like, you know, if you're a nerd, then 255 is a very comforting and familiar number. But it also means that it constrained the distance to anything that can fit in a byte, which obviously, if you're trying to calculate distance in meters, is not great. So I chose the wrong thing there. Yeah. So I think this is it, Hans. Let's have another run. Let me just remove this. Again, you just got to check all your little details. Sooner or later you're going to find where you screwed up. That's not right yet, but I'm sure it must be that. Let me just see. So in 16, so I should have a maximum value of 65,000 now. Distance is 1. Industry is my layer. Maybe Hans is saying I should try a float. Okay. Float 64. The floating point is a big decimal number basically. Let's try it again. I'm still seeing 255s there. That's the sound of me scratching my head a lot. What if we go back to the, let me see, georeference, I just got to go through everything one more time. I know the industry layer is fine. I know that 1 is the industry type. We know that we want to work in georeference coordinates, which are meters. The maximum distance to be generated, let me just put it to a really big number. 65,000, optional. Okay, that's not what we want. That's actually we want to leave that blank, because that's, we're trying to calculate 300 meter distance, but it's leaving the holes in the middle, so I can't do that. Let's do like minus 999.0, which is a old ASCII grid standard way of saying no data. Let's check this here to see if it's reflecting everything we've chosen here. So distance units are geo, okay, values are 1. Have I just hit a wall? Let me see. So, maybe I'll just try a different way. I think I hit a wall here. I don't know why it's not working. I know that these should be showing something. It's like working inwards of the industry area instead of outwards. Well, if it's working inwards, maybe if I do it on the other category, I really should go back and read step by step to see if I missed anything here. Keep all other settings as defaults. Okay, I'm going to just flip this around and do it on this, which I think is 2. Let's have a look here. That is 0, so we're going to do it on 0, and then it should create an internal distance of that layer if it does it the same way, of that class. Oh no. Oh my god, let's see. Okay, Hans is suggesting I should recreate the industry layer. Yeah, that layer is really weird for me. I'm going to make it with the Raster Calculator rather than the Reclassify tool, like I did with the other one. So we know, let's just go back and look at this houses layer just to refresh what's in here. No, not that houses layer, so we know we need to look in the input layer script here. Houses, yeah. No, not that one. This one, buildings. Buildings, okay. So we want to classify everything that's greater than 3, greater than or equal to 3 as 1, and everything below as 0. Let's go and have a look at Raster Calculator. Buildings is, we can say greater than 2, just to make it simple. And we're going to call this industry. I'm just going to remove the existing industry layer. I can't do that right now. Let's run that, move that up to our other group. Okay, so that looks better, right? Now we can just go classify this. So we've got 0 is undesirable, 0 is desirable and 1 is undesirable. We just can classify this quickly. Industry, good stuff, whatever you want to call that, yeah. Alright, Hans, we're going to make it work now. Let's see, okay, so and can I say how nice it is having the book author sitting in with me while I'm going through the chapter. I know not everyone will get that experience, but it does make it fantastic just to be able to ask you things. I guess everybody in your classroom does. So we've got industry as the input layer. We want distance from the 0 pixels, which are the industry pixels. I'm going to call that industry distance. I'm going to take this one away again. Save my project. Run that. Oh my god, it's still doing it. That's now no data. Maybe that's because I've got no data as the value here as well. Let me just see. Or maybe no data is registered as the no data value for the layer. For the input layer. Let me try switch this over to 1. Now these are all 255s. Hence I'm trying 2 approaches now, but neither of those is working. I'm going to try go a little bit more off script and see, because I think Grass has a... I don't think we're using a Grass tool here. I think we're using GDAL proximity here. But Grass also has a tool that will generate distance surface, I think. I'm just going to see what else we have in the toolbox. I just wanted to always like to just reread it again, see if I did something wrong. So sometimes maybe even just closing that tool, I don't know, closing and opening it might make a difference, but I don't think it will in this case. So I'm just going to go look in the processing toolbox and see what distance tool. So we've got that one that we used. That's the GDAL one that we just used. Our distance. That's going to do it. First we need to give 2 input rasters for computing inter-class distances. PC raster's got this other tool here. I think my PC raster, I don't think it's working right now. I need 2 layers as well. Check the screenshot on page 65. It says 65. So, okay, let's just try again from scratch. Maybe a clean start here. So, on your screenshot, it chooses industry. We know that we're happy with the industry layer now, because it's got the good stuff in the industry there. And that layer is 0 is industry, right? And then you didn't fill in anything for the list of pixel values. So how does it know what's going to be the target if it's calculating a distance? I know that it's optional. Maybe it considers all non-zero pixels if you don't fill it in, I'm not sure. Then pick geographic coordinates 0, 0, 0, and that's all, that's it. So let's go and put our output layer. And we're going to create that as industry distance. And run it. Same deal. So maybe something in GDAL changed its behavior, or what's like tantalizing is that is it doing exactly what we want here, and then if it's stuck on byte again, we could check. Nope, it's uploaded it to. Will there be any difference running in there? There should be no difference when we run it in the terminal, right? Because this is basically sending that same terminal command to the from QGIS. So let's put it somewhere else. Let's try and just drop this in QGIS and see what it looks like. Ooh, it looks totally different. Now there's a head scratcher. That looks like what we want it to look like, I think. It basically looks like decent polygons with... Oh man. How's that for a head scratcher, Hans? It's exactly the command I pasted out of QGIS and it runs fine. I'm absolutely flummoxed. I don't know why it's doing that, but I reckon if I put that same command in like that and write it into that folder, and delete this layer, delete that one there, and go drop it in from my folder here. That's weird. So that one, you know what's going on. I know what's going on. There is an XML file sitting in that folder. I bet you it's got all the styling rules in it, and it's just screwing with us. If I delete this both and then run it in QGIS, well, that was a happy way to spend an hour. So I'll explain again what happened in a second, but let me just confirm that that's right. So I go back to, I need to run that tool again, proximity raster, and then we're going to go through all the options again. So we're going to take the industry layer, leave that as, let's just check the picture, leave that blank, put that to georeference coordinates 0, 0, 0, 0. We write this out to inddist.tif, and then run, and voila. So to explain a little bit for our dear viewers who've been patiently watching me trying to wade through this. What happened was that the first time I played with it, and I did I created the wrong output. GDAL, when it opened that output, it automatically created this little file, or maybe when I did some classification on it or something. Let's have a look here. We don't actually see that file now, but somewhere along the line I created a little one of these orcs.xml files. Probably when I when I classify the Hans is saying I always use a unique. So I should have called it in distance 1, 2, 3, 4, 5, and so on. For each try that I made, and I wouldn't have had the problem. But because I was overwriting the file, but it was using an old one of these files, and we can open this with a text editor just as a quick diversion. You see, it's got all these cached things here about what the layer properties are. And if you cache the layer properties of an old layer and then generate a new one, it didn't like replace the cache with the new value, so it had like the range was still set on byte basically, and who knows what else was in there. So cool, we solved the problem just with a bit of patience and checking, rechecking, and rechecking. Okay, so now we've got a like an intermediate layer, but it's not actually one of our criteria, right? So we could maybe make another group here for intermediate whatever layers. And we can drop this one in there, because actually what we want to do is now filter this layer by all the pixels which are less than 300. Where's my intermediate layer gone? Okay, so I'm going to put it in the middle, keep things organized. So we want to filter that by ones which are less than 300. So here we go, Raster Calculator, industry distance. So we want it greater than 300 to show the pixels which are good. Let me see if that's what he says to do. Greater than or equal to 300. Okay, so greater than or equal to 300. Alright, and then we're going to make that now. What is this one going to be called? It's going to be called ind 300 meters dot tiff. Okay, ind 300 meters dot tiff. Save. Alright, and we run that. And perfection should happen. Let me see. Yay, that looks exactly like the one in the book. We have gone out of a state of flux back into being on track to be, to be getting everything done as the book requires. So, and then I can see there already that he's gone and set some styling for that, so let me do that as well. Classifier, so this is again discrete layer that we've made. This is, just see, that's bad areas, or industry areas, whatever, industry areas, what did he call that? Okay, he called it, he put the distance, but I don't think it's too critical if I call it something different here. Okay, cool. Alright, so now for our criteria we've got areas which are within 300 meters of a industry area. We've got roads, areas which are within 150 meters of roads, areas which are industry, which I think this is an intermediate layer. We're not going to need that again. I think, could be wrong. I'll bring it back if we need it. Areas which are within 150 meters of a house, and wells which are not too deep. Alright, so combine the three conditions to and report the results. So I'm wondering what the three conditions are, because we have four. So we've got 1, 2, 3, 4. The three conditions. We go back and look at the chart in the beginning of the book, of the chapter. He has got three conditions, which are the 150 meter buffer from houses, 150 meter from roads, and the distance to industry or land use, which has been reclassified to 300 meters. So I think those are the three conditions he wants us to combine. So if I look at the screenshot, we're going to do a new Raster Calculator expression. We're going to do all the cells, so we're going to use the AND operator, which means basically all the cells which meet all the criteria will get scored a 1, and all the ones that don't meet one or more of the criteria will get scored as 0. So I'm going to take that one. Now what's funny is that he's got 4 criteria here. Let me see. Houses, roads, industry, and not deep. So why does it say 3 conditions, but we actually have 4 in the calculation? Is that just a typo? Let's see. Houses, industry, not deep, and roads 150. Okay, so according to the screenshot, we're going to be using, let me read carefully what it says. Use the Raster Calculator to combine the 3 conditions. Because all Boolean results for the conditions need to be true, we have to use the AND operator, figure 3.24. There's for sure 1, 2, 3, 4 criteria in here. So maybe it just needs to be changed to 4 at the top in the title. Call the output layer accessible worlds.tiff. Maybe I missed a nuance. I'm just going to underscore that to keep consistent with the rest of the layers I've made. And I think we're ready to rock and roll here. Let's go. So why does that look different to oh yeah, so if you see I'm switching on and off the second layer. Let me go and make this transparent, and that will also make it easier to see. I'm just going to add a transparency. I can just do it more simply like this. I think it's 1. Let me see, yeah. So here you can see 3 worlds, which I got those the wrong way around, didn't I? Because where's those industry? I've got wells which are in the industry area. Oh no, they're not. No, that one's in the industry area. Put all the things on. I would have thought the 3 down the bottom here are the accessible ones, and the others are inaccessible. Maybe I just need to code this up a bit differently. So just take that away there. Classify it. No, so those for sure are accessible. That one should not be accessible because it falls inside of there. Okay, so Hans is correcting me, saying it's 3 conditions because condition 1 is for both roads and houses. That's now referring back to your diagram at the beginning of the chapter. Alright, I won't dwell on that, but what I'm more confused about is why this little pixel here, I don't know if it's easy to see on the screen share, is yellow. And why these ones are not yellow, because they look like, so let me just work through these. So these not deep ones, if they're too deep, they get green, so let's just check that quickly. too deep are green, so they shouldn't be included in the criteria. What could be happening is that I might have flipped around some of my logic. So too deep, if we're doing an AND with too deep, we're actually ANDing the not deep here. So I think there's a little nuance going on here. It's again me just bumbling my way through here, is that if we look at this result layer here, these ones are coded as 0, and the not deeps are coded as 1. If we're ANDing, we do want that should be true in the AND condition, so that one's good. Let's go through each layer. Yeah, Hans is also afraid I flipped something somewhere. If I flipped any of the meanings, then the AND is going to break. So I need to check that I've done everything right. So industry areas, we basically want the good thing always to be 1, right? So the good thing here is 1. The good thing here is 1. Let's classify this. Oh, we have this weird thing. Maybe this weird thing's coming to get us now. I sort of tried asking you, I don't know if you replied, Hans, but I couldn't understand why the roads themselves get coded as 0 instead of 1. And I think that's the reason, maybe, because that one's in a road thing, so that's why it's getting flipped. And I think the same with the houses. So I think those layers are fine in as much as the coding is the right direction. That's the good thing. This is the, let's just check that again. So that's too far, and this one is close enough. Alright. So I need to figure out why, when we do that proximity calculation, it puts no data in the middle there. So if I go back a few steps and try to calculate the roads, I'm just going to make it like a scrap folder here. Actually, they can go in my scrap folder. Alright, so let's go and calculate the proximity for roads again. Roads. We were trying to do it 150 meters. So I did it off script, I think, because I put in a value here. Now if I do it with no value, like we did the last one, and I put this to geographic, and then we set it to float, whatever, that's fine, and we choose the output, save to file, and call this road distance, or something like that. Road distance .tiff, and then we create that new layer. Now I've got, let's just hide all this stuff here. I've got distance from roads, and then if I do a Raster Calculator, these ones here should be 0, 50, so everything less than 150 we're going to calculate here. So road distance less than or equal to 150. And I'm going to overwrite the road 150 meter layer and maybe delete that XML if it has it. Less than or equal to, okay, road distance less than or equal to, woohoo, okay. That looks good. We don't have that little line in the middle anymore. I'm I'm going to just look at Hans's book to see if he's got a screenshot here of the roads, how they came out done. I don't know if there is a screenshot of them, how they came out for him. But anyway, I think that looks better because now all of those should be within 150 meters of a road. So that we're going to put back into, well, back into our criteria here. And delete the other roads. 50, we can copy this style here. And we can delete this one here. Right, and now I need to fix the houses 150 as well. Because we've got the same thing with these dots. Although I think in Hans's screenshot here, little dots in the middle too. I'm surprised why you didn't have an issue when you... Maybe you didn't get the issue with the houses because... Hang on, yeah. I don't know why you didn't get an issue with those. Let's do the houses the same way we've just done that one now. So we go back to our scrapped folder, or our intermediate layers folder actually. This one should be in here. And we're going to do a new one which is the proximity to buildings, and I think the criteria was also 150 meters. Yep. So let's take buildings. We're not going to fill in anything there. We're going to set that to georeferenced coordinates, and we're going to save this as building distance, so without distance, no, not with 150 in it. Building distance.tif. Right, and so let's run that. We should have a new surface. Let's keep that open while we check. Building distance.tif. Alright, and then we can do the same trick again of let's just copy that style and remove this one here, and we'll remake this layer again. So now we do Raster Calculator. We're going to take the building distance is less than or equal to 150. I'm going to write that out to our building distance 150. Buildings 150. Where is it gone? Houses 150. Cool. Let's see how that came out. Cool. I think that's more how it should be looking. Hans is saying it's not the issue, but I want to just check, because let's try run it again now and see what happens if I use those same criteria again. But in a way, I think this is cleaner, because now I know that every distance is from a house, including the house, is covered in this. Although this looks different to, it does look different to your picture now. A little bit, maybe. There's more stuff going on here than in your picture. And in Hans's one, he's just got two little blobs here. I'm not sure why that is. But let's go and just run that raster analysis again, raster calculator again, and combine them all together and see. So we're going to do, and write that out to accessible wells. Here. And we're going to say house is 150 meters and road 150 meters and industry 300 meters. And what was the last one? Houses, roads, industry, and not deep. Let's put that in my clipboard so in case I need to do that again, I don't have to work too hard. I should have kept the old one so I could compare it, but let's do all the wells and then where was our other wells layer? What was the old one? That was the not deep one. Compare that to, I just want to make this transparent here. We've got exactly the same thing out. So yeah, it's another problem. Wait a minute, so there's 3 black ones there. See, to my thinking these 3 would be the accessible ones, but no, I think that's perfect. I think what it did was it coded the others. I actually don't know why it was showing them all before, but I think that's done correctly. Let's see what we're supposed to get, because I haven't even looked on Hans's book to see what the results are going to look like. Yeah, I think that looks good. Alrighty, so I think we found our accessible wells. Woohoo! It was a bit of a journey, and I'm probably going to not make it through the whole chapter tonight because I'm not sure how long I've been streaming for, but I need to go and look after some animals and things. But that was a bit of a journey, but we learned a lot of things along the way. The one is, I just can't emphasize always how important it is to just check all the small details. If you just click blindly and do stuff, you're going to get just weird stuff happening, might not be consistent. And then try to think logically, like what is it you're trying to achieve? Is everything you're doing consistent with the goal you're trying to achieve? And then work through systematically and like look at all the small details and look to see if you've broken things like like I did, having that little XML file. It's just like, if needed, to start in a clean folder and just do everything again, fresh, checking all the details. Then we've also just learned some cool stuff about using Raster Calculator, the proximity distance tool, and how you can combine different layers to create like these multiple criteria analysis kind of output. So I think I'm going to stop there. I see Mohab is in the room as well. How's it, Mohab? And Hans has confirmed that everything's correct that I've got so far. So tomorrow I'll carry on from here, and I can see we're going to be turning those 3 dots into a point layer, and then we can make a nice map and style up the results and everything. So that should be quite more easygoing, I think. Alright, and there's some comments from Mohab, so let's quickly just cover that. So he's saying he's asking whether it goes into detail describing the algorithms themselves and how they work, and so Hans is replying, this book is more aimed at beginners. And I definitely think, yeah, if he'd gone into the weeds about the actual algorithm logic themselves, we had enough over time just keeping all the different layers sorted out properly and so on. Hence, I'm still a bit unresolved about the 4 versus 3 thing, but I need to go just read carefully why you say that there are three layers but 4 inputs and whatever. But I'll go read your materials more carefully offline and have a look at that. So thank you for joining, everybody who joined us. We've got currently 148 people watching. I don't know where you're from, but please do say hi in the chat room if you're watching and getting value from this, or if you want me to poke into more detail at things or explain things better, or just say hi. Those are all great things to do, and thanks for watching. I'll be back online tomorrow. We'll continue the journey through Hans's book. As a quick last reminder, you can buy this book online. It's reasonably priced. It's got a very good value. It's a very nicely put together book. So if you're looking for it, you can buy it online here. I think I did put the link in my show notes as well. So do support Hans and the great work he's doing by going and getting a copy, and maybe you can have as much fun as me following through the exercises. So thanks for watching, everybody. We'll catch you next time, and signing off for now.